Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about your favorite open source projects. My name is Anthony Skopatz, your host for Open Source Directions. Co-hosting with me today is David Charbonneau.
Hi, I'm David Charbonneau, and I'm excited to be the co-host for this episode of Open Source Directions. I lead the development of the Open Teams initiative at Quansight, and I'm based in Durham, North Carolina.
All right. Hi, everyone. I'm Philip Ridiger. I'm really excited to be here. Thanks for having me on. My original background is in computational neuroscience, but for 3 years now, I've been working at Continuum, or now Anaconda, on being a consultant. And I've maintained various PyVis projects, including the GeoViews project we'll be talking about.
Excellent. Thanks, Philip. So before we dive into GeoViews and kind of what it is and what it does, we'll do our quick personalization section. So first up, we're going to talk about our tweets of the week. And so here, each of our panelists is going to present a tweet that they've been enjoying recently. So Philip, you're up first.
Yeah, I'll get started. Mine's not too personal, but mine's about the MindBinder project, which has just announced that they've served 2 million sessions now. So if you're not familiar with MindBinder, it's a platform for serving computational notebooks, which is free, and I think it's a really great thing for reproducibility.
Yeah, that's awesome.
That's cool. My tweet this week is from, I think, Redit Abibi, maybe. She published a paper on simplicial closure and higher order link prediction. I haven't read the paper in depth, but it looks very interesting. They watch networks as they evolve over time, look for higher order structure, and then try to predict future interactions. So kind of cool stuff.
Cool. Thanks, David. On somewhat of a lighter note, the Microsoft developer account this week said, coworker, hey, new glasses. They look good. Me, thanks, ... But my brain says, don't say it, don't say it, don't say it. Me, they help me C#. So, all right, I couldn't resist the pun. All right, so let's now move and talk about GeoViews. So we've got our standard first few questions that we're just going to go through. GeoViews is an open source geographic visualization library. It's built on top of HoloViews and Cartopy. We talked about HoloViews a bit when Jim was on for the PyVis episode. So if you want to go back and watch that, you're welcome to. They're both open source projects. GeoViews has about 185 stars on GitHub and about 3,000 downloads a month, combining PyPI and Conda. So I think with that, David, you want to take the first question?
Sure. Philip, why was this project started?
All right. So after joining Anaconda, we started doing some consulting projects, and one of the first ones we got into was one with the Met Office. So they were hoping to explore. They have these gridded data sets of like temperature data changing over time or precipitation, and they needed to explore these. And using Matplotlib, you can build little apps that let you move through time, but it's kind of can be quite painful. So HoloViews was designed originally for our PhD, where we explored so neural networks evolving through time. And so we thought, well, that could be leveraged for geo applications as well. So that's how it started. We started building on top of Matplotlib and Cartopy, basically projecting data, allowing it to project data and display it, and see these data sets evolve through time. With sliders and so on. And then after the Met Office project finished, on my own time, I was really interested in bringing the Bokeh support, which we'd added to HoloViews by that point, bring that to GeoViews as well. And from there on, it became like a very much more interactive project, which allowed you to not just use sliders to explore a data set through time or other dimensions, but also actually zoom in into your data and so on.
Excellent. Thank you. That's very cool.
Yeah, that's great. So what need does GeoViews fill precisely, if you were to categorize it?
Yeah, so I already got into that a little bit, but so one of the main uses, of course, was to basically geographically situate data that you maybe already using HoloViews, and now you wanted to geographically situate your data on a map. But you also, another major use was basically exploring really large data sets. So very large raster data sets, which are very common in climatology, meteorology, remote sensing communities. So these can't, I mean, with Matplotlib, you can render static images, but if you want to zoom in and so on, your browser can't handle these large data sets. And so we really tried to make it so that you could dynamically data shade these data sets. So we have strong integration with the data shader library, which allows us to deal with these large data sets and basically scale them using Dask, another open source library. And then a major benefit of using HoloViews was that you could use data from different sources. So gridded data sets, either using X-ray or Iris, tabular data sets, which were stored as arrays, as Pandas data frames, or geometric data, like shape files and so on. And GeoViews really was meant to make it really easy to combine these different data sets and put them on top of each other without really trying to dig in. How do I get this data into this plotting library? GeoViews and HoloViews natively understand your data, so you literally just put it in this wrapper object and then it displays itself.
Are there any alternative projects out there?
So yeah, I mean, the plotting space is very crowded. The geographic plotting space in Python maybe not as much, but there is obviously Cartopy, which is what we're building on, which allows plotting with Matplotlib. So it handles the projecting for you. There's also Leaflet or IPyLeaflet, which is the Python interface to that, which also allows to display things on top of tile sources, and also has some interactivity. And finally, there's Plotly, which also has some integration for geo support, although I'm not that familiar, so I can't really comment on how fully fledged that is.
Yeah. So you've talked a bit about this, but what technology specifically is GeoViews built on top of? I know it's part of the PyViz project, broadly speaking, or the PyViz initiative, broadly speaking. But
yes, so it's one component of this broader initiative to really make it easy to deal with these very different data sets in the PyData ecosystem. So there's different components. So first of all, as I've mentioned, it's built on HoloViews. It simply extends HoloViews to give it understanding of geographic data. And then obviously the main component is built on Cartopy, which allows us to hook into basically declare what projection some data is in, and then project it to another projection for display purposes. So if your data is in some very custom projection, you can project it onto a map and display it that way. So those are the main core components. And then there's the data backends, which allow GeoViews and HoloViews to natively understand your data. And that includes libraries like X-ray, Iris, GeoPandas, and so on. All of those are natively understood. And then obviously the actual plotting and rendering components are built on top of Matplotlib, first of all. But what we've mainly been focusing on recently is the Bokeh support, which allows us to do things like cross-filtering, zooming, and even drawing on top of a map and annotating the data.
So I think you might have mentioned part of this earlier, but who started the project?
Yes, so before PyViz was a thing, we had a little group within Anaconda or Quintinium at the time, and it was us that started it in collaboration with the Met Office, and from then on we've basically taken over the maintenance of the project.
Wonderful.
what is Met Office, just as like a...
Oh, yes, of course. I should have brought some
clarification.
Okay, so the Met Office is it's a short form for the Meteorological Office, which is a government agency in the UK, which basically does weather forecasting, but they also do more research type focused projects, including climatology projects and so on.
Ah, cool. Great.
What are some of the communities that users and contributors are coming from?
So one of the main communities for us has always been our clients, of course. But beyond that, we've got very scattered users using it for their personal projects. And then there's, among the GIS community, we have a lot of people working for US government agencies, including places like the U.S. Geological Survey, NASA, or the U.S. Army Corps of Engineers, which we currently have a project with. And then out of that, among the research community, we've also recently been engaging with the Ngo Project. So that's an initiative run by various climatology or I can't say that word, oceanology researchers who really are trying to bring cloud computing, bring the computing to the cloud. So they have some Jupyter Hub deployments, which allow you to really scale your analyses on the cloud and do your analysis, visualization, and so on there. And they often work with very large data sets, which we can handle using both Datashader and Dask.
Awesome.
Very cool. Yeah, that's awesome. Is GeoViews participating in any diversity and inclusion efforts?
So GeoViews is still a relatively small project, and we've not been very good at general developer outreach or community building, which is, I think, a major shortcoming of ours. So we're trying to transition to become a more mature project at this point. So we're looking for active participation from anyone, first of all, to really make the project more welcoming, provide materials to introduce new developers, setting up a code of conduct, and so on. And then actually bringing a more diverse leadership and developer community into the project.
Sound like good first steps. So, yeah.
Early steps.
Early steps, right? Yeah. All right. Well, I think at this point, so now that we have a good background feel for what GeoViews is, it's why don't we do some demos? Like walk us through the project a bit. I know you have a couple things prepared, so maybe if you want to go ahead and share your screen, Philip, that'd be awesome.
That's right.
And this is always a fun part, right?
Yes, particularly for a visualization project.
Right, exactly.
So first of all, GeoViews is obviously open source, so you can find us at GitHub, PyVis GeoViews, and we've got the website, geoviews.org, which has various user guides that kind of introduce you to the project. So the first thing I wanted to introduce you to is the basic concept behind GeoViews. So how does it work? So HoloViews, which it is based on, has these concepts of elements, which basically express what your data represents. So you might have a set of coordinates, for example, with some associated label. So here we have coordinates of various cities, New York City, Beijing, and London. And those might be in different coordinate systems. So here, for example, we have longitudes and latitudes, but then we've got this weird format here, which is actually Mercator coordinates. So here you can see how you express kind of the data. So here we're expressing that these are a set of points, and they're cities, and they're located in lat-longs, which is the default. But then we also can declare that here the actual coordinate reference system for this London data point is Google Mercator. And by combining these, we can then put them on the same map. So this is the basic concept behind GeoViews. It wraps up your data along with a declaration of what coordinate system it is in, and then it just displays itself. It does all the projecting for you and places it on a map. So here we also provide various tile sources, and that's the very basics.
And this looks like a bokeh figure, right? So I imagine
That's correct.
It's 100% interactive.
Yes, that's right. So you can zoom and pan. You could also, the nice thing about GeoViews and HoloViews is that it lets you switch the backend. So if you wanted to render it to Matplotlib and output an SVG or something, you could simply change this to HGV extension and then just list Matplotlib, and it would switch.
Awesome.
So that's just the very basics. We support the Cartopy provides a huge number of projections. So here you can see this is mole-wide projection. You can see all the supported projections here. So that's quite a few.
Wow, yeah. That's more than the Wikipedia page on projections.
That's nice. Yes. So that's all provided by Cartopy, all the projections, and we wrap that up in nice ways. So we have basically a general project operation, which takes any of these elements and takes them from one coordinate system and puts them in another. So here you can see we've again put them in as longitudes and latitudes. And then we could say, actually, we want to project these. And then what we get back is another points object, but now the coordinate system has changed to Mercator. And you can see that the coordinates have been transformed. So yeah, this is the very core of GeoViews. Basically, a way to wrap your data along with this additional metadata, and then it knows how to handle projections for you.
Just as a quick question, what's the advantage of using Mercator versus lat-long? Is Mercator better at like being stored as an integer or something? Like, why would you
generally, the only reason is that a lot of the tile sources in the web, particularly, so these map tile sources where you can zoom in and out, and as you zoom, it gives you more detail. These are usually in Mercator. So if you want to overlay something on top of these, you generally have to put it in Mercator. There's huge problems with Mercator too, which I won't get into too much detail, but it basically distorts the data quite a bit.
Sure, yeah, that's a different webinar, I suppose.
Yes, that could be I could rant about it, but
sure.
No. Okay, so that's just the basics of GeoViews. I'll talk a little bit about the different data formats that are supported, and particularly an extension library that we've built to kind of bring plotting directly to your data. So most of you will hopefully be familiar with the data frame plot interface, and HVplot is a replacement for that, which gives you all the interactivity that Bokeh plots provide. So if you simply install HVplot and then import, for example, hvplot.pandas, you'll get an HVplot method on your pandas objects, which will let you plot much in the same way as pandas.plot would do. And this is a really nice, easy entry point to plotting with both HoloViews and GeoViews. So here you can see the different data formats it provides. So for example, here we have a data frame of various airports in the US. And we can simply say airports, HVplot points, and then it will situate that on our map, and we can again overlay it on a tile source. And this supports a wide range of data formats. So for example, GeoPandas is supported. So you can simply load a GeoPandas data frame, say HVplot, and it'll plot it on a map. And so here is just point geometries, but it could be polygon geometries. So these are just the continents and countries, and that's supported too.
That's awesome.
And finally, the third type of data, so I generally talk about it in three ways. So tabular data, geometry data, which is GeoPandas and Shapely, and finally gridded data sets, which are usually best represented by the excellent Xarray library. And again, if you import hvplot.xarray, you get this hvplot method, and you can, for example, explore a data set of temperatures varying over time and project that onto a map and then explore it over time. So this is a static rendering, in which case we usually don't embed all the data. So this slide right isn't actually doing anything. But if you run this in a live notebook, it works fine.
Do you do you support like unstructured grids at all, or do they have to be strictly structured in some way?
Structured. So we've recently been adding support for tri-meshes, which is one form of unstructured grids. And we can even, the data shader library now has a way of rasterizing those tri-meshes into, so rendering tri-meshes, particularly in an interactive way, is really expensive. Like you have to render each individual triangle, which is a lot of data. So data shader basically turns that into a fixed size image, which is actually also what I've done here. We've rasterized this quad mesh, which is also pretty expensive to render, onto a simple raster image, which makes it much more amenable to plotting in your browser.
I see. I guess a natural next question there is about sort of GPU acceleration and things like that, right?
That's a really interesting question. So that's something we're currently considering. There's a new project by Rapids AI, I think, which is basically a GPU data frame. It's really nice to start leveraging that kind of thing to do this kinds of aggregation type operations on the GPU. Right.
We've been doing some of that work here at Quansight, and I know you some folks at Anaconda have been doing work on that as well.
Exactly. So, yeah, the number
in
team
collaboration with NVIDIA. So yeah. Excellent.
Okay. So HVplot is basically a really nice and easy way to get into starting with GeoViews. But you can always fall back to actual GeoViews. So that's kind of the introduction. Won't go into too much more. I'll show 2 more demos, I think. So we've
I think
also
we
got,
might just have time for one, actually.
okay. So we'll go straight to that. Okay. So one project that we're currently working on, which is kind of building actual workflows around this library. So one thing you might want to do is basically annotate some data or have a workflow that requires multiple steps. So here, what we're doing is an example workflow where we're selecting a region in this space. So we can say, we might select the region. And then in the next step, we use that region to download this particular tile. So we get the image of the tile. We can then use these drawing tools to annotate this data. I'm doing it wrong right now, but we might want to say, so the whole output of this procedure is basically extracting a contour from this coastline, which might be input to some environmental simulation or something else. But really, it's just a demo of the kind of workflow that you can build using GeoViews and now this panel library that we've been working on, which allows building dashboards. So the way this works is you draw something, and then it extracts the contour for you when I click these buttons. It takes a few seconds, so I won't do that now. And then finally, you can basically extract the contour and turn it into a polygon and export that and put that into your simulation.
That's really cool.
Yeah.
So, and the cool part around panel and combining panel with GeoViews in this way is that not only can you do it in a notebook, but you can then take these different stages, combine them into a pipeline, and then serve that as a separate app, a completely standalone app, which basically lets you do the workflow outside a notebook. So for someone that's not too accustomed to programming interfaces, you can then deploy this as a separate app inside your organization or even publicly.
Wow.
So here is the same workflow, but now you have a linear pipeline where you just step through these different components.
That's awesome.
Very cool.
It's really neat. At this point, thanks for that awesome demo. That's really cool. But at this point, we're going to transition to sort of the meat of the episode where we're going to be talking about the GeoViews roadmap. So broadly speaking, we're going to be discussing where the project is going, what are some of the wish list capabilities. These are that you'd like to see in the future. These are things where if folks were interested in coming on and contributing and being part of the GeoViews project, they would be able, these are points where you'd love to have help and support. Or on the other hand, if there was funding available and someone wanted to fund a particular piece, this is something that you're already thinking of doing, and it's kind of like a ready to go if only the money and personnel were sort of there. So the GeoViews has a roadmap. You can go and find it at quansight.com/projects, where you can see not just the GeoViews roadmap, but others. But we're going to go ahead and talk about kind of the top few issues on the roadmap in terms of importance. So David, if you want to go ahead and take the first one.
To kind of get started, how would you describe the overall vision for GeoViews, Philip?
All right, so the overall vision, you kind of need to see it as a whole. That's why we have this overall PyVis initiative, which really is meant to be a way of flexibly combining different visualization components and PyData, things from the PyData ecosystem, into a general flexible toolkit to kind of build applications that you need. Mm-hmm. And so we're overall in the GIS space, there is these either closed source or native GUI tools, such as ArcGIS or QGIS, which are really, really powerful. But they're also, being native GUI tools, they're often not as flexible or a bit hard to extend. And there's many such tools in this space. And so we're really aiming to have the PyVis ecosystem and GeoViews be a way to build flexible things in a notebook and then deploy them as apps in a way that's not as limited.
I like that workflow, that ability to kind of experiment and share and discuss, and then put that out as the part that's the actual application and make it available. That sounds like a great vision.
Is that sort of being driven by customer need in some sense, or what's driving that like ultimate vision, I guess? Or is that just something that
I think I mean, it's a general vision that I think we've had for a while, and there's lots of people working on this space. So there's always, particularly in the notebook ecosystem, there were initial initiatives to start, like, you can build an app using IPy widgets, for example, and then there was like something like a Jupyter dashboard, which let you then deploy that as a standalone app. And I think that's a really powerful workflow because you can experiment initially, and then once you've got something that you think is shareable, you can then deploy it. And making that transition easy has always been a major goal of ours. But customer needs have really kind of affirmed that's really a powerful workflow.
Right. So if someone wanted to come in and help out towards that vision, or if they wanted to come and say fund a particular part, what would you say they should do? Like how would they get started towards building that broader vision?
So for us, initially, I mean, each individual project in the PyBiz ecosystem has its own little needs. So there are certain things we want to do. For GeoViews in particular, I think the scalability story is really important.
Sure.
We're still working on that. And then particularly about this transition, if you're talking about specifically about transitioning from this notebook workflow to a deployed app workflow, help with the panel library, which I've been building over the last couple of months, would also be greatly appreciated. So even just general maintenance is probably one of the hardest things to convince anyone to invest in, but it's also one of the most important aspects. So building documentation.
Every project ever.
Yeah.
Yeah.
Yeah. The more I think about it, the more I think maintenance is just a really bad analogy for what's happening with what we call software maintenance, right? It's not really the right word sometimes. But that's great to know. That's good. So panel and some of these other pieces that are related to GeoViews and scalability. That's great.
Yeah, I think we'll get into some of the more specific.
Yeah, it's a perfect segue, actually. Yeah. So scalable rasterization of gridded data is one of the particular roadmap items. So could you talk a little bit in depth there about sort of what that means and how people could help out?
Yeah, so in the remote sensing community, and particularly, so if you think about satellite imagery, those are usually hugely detailed gridded data sets. They're several hundred megapixels, gigapixels, and displaying those quickly and zooming in and actually getting all the detail out of those is a really hard problem. So currently we have routines in Datashader that lets us work with these either rectilinear, curvilinear, or unstructured meshes. So that's quite specific terminology, but basically they're all different ways of representing different grids on the computer, and we already have ways to deal with those, but those are all currently in-memory ways. So if you've got a data set that's larger than what you can actually hold in the memory at any particular point, our approach currently just falls over. So we'd like help and expertise from people, and funding, of course, to start building these things on top of Dask, to really start scaling them and bring them to data sets that couldn't usually be analyzed quickly.
Right. That's great. That's excellent. I don't think I have any other questions on that one, David.
Yeah. We've also got mentioned on the roadmap improved integration with the Intake project. Can you elaborate on that?
Yes. So you actually, I'm not sure it was the last episode, but you had Martin on from the Intake project, who also works at Anaconda. So Intake, if you're not familiar and you haven't watched the episode, which you should, basically allows declaring data catalogs, which can either live locally or remotely, and they allow you to basically declaratively specify a data set and then load that in and start working on it. And we already have some integration with Intake. Particularly, we have the HV plot, what I mentioned before, already has ways of basically plotting in Intake data. But so first of all, it's part of the same scalability story. Being able to deal with these remote large data sets is part of that. But then also we're planning on various improvements to, for example, persist. So if you've got this remote data set, you've specified some plot that we want. So we've got this mechanism to store the specification for that plot is part of the catalog. So you can basically express as part of the catalog what your plot is, and then when you load the catalog again, you can simply say intake catalog, just pick your specific catalog, and then say custom plot, and it just brings up the plot that you've persisted. There's still some rough edges there that should make it easier to kind of persist those custom plots to your YAML and make it really easy to basically
I can see that really useful in a wide variety of contexts, right? Like you've got maybe traffic data, or you've got other information that's constantly streaming in, and then rather than as a researcher, if you haven't, say, published this as an artifact yet, maybe you can just go to the catalog, load the plot for the data set you're interested in, and start running some experiments or some analysis, or just looking at the graphs. That sounds really cool.
Yeah. So I think it is a really promising avenue. And along those lines, there's also ideas about building like a data explorer type interface where you'd basically take your intake catalog and simply say, I want to plot this and this against that, and it just pops up your plot for you.
Yeah, it seems like that would be hugely useful to some of the panel workflow kind of application ideas, is being able to specify where your data is coming kind of in a very formal, separate way from the application, and then you just apply the application to whatever data set you happen to have or want to look at that time. So it's a nice idea. And then you get a catalog back out of it. So at the end, yeah, it's nice. That's right.
So that's something we're still actively thinking about. So if anyone has got use cases for that, we'd love to hear those as well. So it's not just about funding, it's also, we really need to hear what people want and need out of these kinds of things.
Yeah, of course. Yeah, that kind of feedback is invaluable. So, so you are working on integrating sort of 3D Earth rendering into GeoViews, or you'd like to be working on that? Could you?
I've prototyped a little bit. So okay. Some of our customers have wanted that. So one of the core design decisions behind HoloViews was that it would have customized, you can extend it with custom renderers. Currently, we've mainly focused on the Matplotlib and Bokeh backends. But you can extend it with any render that you want. So one of the things that we experimented with was a Cesium.js renderer, which is a 3D plotting library. It basically gives you a 3D globe that lets you basically situate things in a 3D environment rather than the regular 2D plots that you usually see. And that's one thing that if someone were interested in developing that, that's something. It's a really fun project to work on. So we'd like contributors or people who want an easier interface to start plotting on a 3D globe. And that could be based on Cesium.js, or so Uber has this really cool project called DeckGL, which also is a 3D rendering interface for really large data sets as well.
I see. Is that specifically for Earth rendering, or is it just generic 3D rendering?
I think it's as far as I know, it's mostly focused on geographic rendering.
Oh, okay, yeah. I mean, that makes sense. But
I think those are their workflows. Like they visualize all the different taxis they send around and things like that.
Right. Yeah. Cool. I hadn't heard of that. It's neat.
So, are there other projects that you're looking to improve integration with, or provide additional tools around?
Yes. So I've mentioned intake, but generally we we already have pretty strong integration with Datashader, and Datashader is a good place to kind of add. Basically, the core of Datashader is this number backend, which basically does fast aggregation, rasterization type operations. And that's been expanding a little bit into the GIS space, doing things like computing hill shading operations, doing NDVI, which is satellite vegetation index computing. And basically, we want to extend that to common operations in the GIS space, doing things like zonal statistics, building hydrology modeling tools, which includes things like flow accumulation, but also things like computing Euclidean distances on input geometries, and basically just extending the types of tooling around the GIS space that we have.
Fantastic.
Excellent. So yeah, sounds like another great place for folks to get involved, either by contributions or through funding. You also have listed here, this seems very similar to what we've already discussed with respect to intake, but kind of better support for remote data sets and remote computation. So maybe we haven't talked about the remote computation piece in particular.
Yes, we haven't really.
Yeah.
So a lot of we provide support for Dask, particularly. So we ingest Dask data frames directly. We can ingest Dask arrays, and actually Xarray also natively supports Dask arrays. And ideally, we'd never leave that space, right? We always leave things in Dask so that that handles all the memory. We can deal with data sets that are much larger in memory. And that doesn't only include things like doing rasterization in a Daskified way, but also doing other operations, including projecting of data using Dask. So generally, we want everything that we do to be scalable using Dask.
Are there pieces of this space in GeoViews that wouldn't be necessarily like embarrassingly parallel? Are there rasterization problems that are not embarrassingly parallel? I'm just asking, like, since that's not an answer I know.
Yeah. That's also not an answer I can answer easily. I think mostly it's not a straightforward problem, but I don't think there is anything that's an esoteric research problem that would have to be solved. I think there's solved problems that are hard.
Okay. Yeah. At least we know where in the space these things are. So yeah. Okay. Excellent. Is there anything else that you wanted to add to kind of the roadmap discussion, just in general, kind of any miscellaneous items that we didn't have a chance to talk about before we transition?
No, I think we've covered most of what we want to do.
Okay.
I mean, there's certain bits that are fun to do. There's like, it would be nice to be able to do cartograms, for example, in GeoViews. But those are like nice to have items, which I think, maybe aren't too applicable to some industry funding source or whatever.
Right.
It's just fun projects that someone could work on if they are so inclined. Right.
Yeah, another place to contribute if you want. All right, that's great. So at this point, we're gonna transition on to our question and answer session. So folks this is your last chance to ask a question in the chat room if you'd like to ask a question. We already have a couple loaded up. So first off, from Twitter, I believe, Benjita asks, is it possible to import other raster formats into GeoViews/HoloViews other than the netcdf files shown in the tutorials?
Okay. So yes, I'll try and answer that. So in general, we don't try and do the ingesting ourselves. We try and we basically natively understand various in-memory or out-of-core formats, including Xarray. So Xarray has a wide array of backends which it can load from. Which include netcdf, but also grib files, geotiffs, and more, which I'm not actually that familiar with all the different interfaces. But anything that can be loaded with Xarray can be ingested. Same with the Iris project, which is the Met Office equivalent. It's kind of a very similar project to Xarray, but I think maybe has a slightly different array of formats that it supports. And then obviously, if neither of those support the kind of data that you want to load, you can always fall back to NumPy. If you can get it loaded into NumPy, you can display it, basically.
Yeah, NumPy or Pandas, right? So.
Yeah.
Okay. Yeah. Huge variety there.
Samir Lolwani asks, is there any direct interaction with GeoPandas? For example, is GeoViews aware of projection systems being used in GeoPandas?
That's a really good question. So that's actually new to me. I didn't know GeoPandas really represented projections. So I'd encourage Samir to file an issue with GeoViews to outline, what support you'd want out of that. I think we can, as long as it's straightforward enough to convert these coordinate systems to Cartopy coordinate systems, it should be fairly easy to load them in and then convert them.
Excellent. Well, I don't believe there are any other questions that have gotten added. Oh, David has a question. Wow.
Yeah. So I was just wondering, Google, for example, came out with Google Moon and Google Mars, and since you've got this geographical mapping capability, has anyone suggested or attempted to use GeoViews for doing maps over other celestial bodies?
So there's been some people trying out, and they've from the AstroPy community. So AstroPy is a really big project. It's used by lots of astronomy people, and they've played around with HoloViews itself a little bit, but I haven't yet tackled those kinds of coordinate systems. It would be really nice if Cartopy could be extended to support those, and then we just get that for free, right? As soon as Cartopy supports it, we support it. So I think that's a cool item to work on if anyone's interested.
Is that? Yeah, are those coordinate systems fundamentally different than Earth-based coordinate systems, or it seems like they'd be very similar?
Yeah, I would think they're similar, but I'd let David answer that.
Okay.
I have no idea.
You're not an astrophysicist, David?
No. Don't even play one on TV.
There you go. Samir is typing something I can see in the chat room, but so I want to get the question if there is one. But before we move on, can finish up really quick here and hit enter. Otherwise, we might just have to move on and answer after. Oh, there we go. Okay. The comment is just, I use GeoPandas to handle LiDAR data and to reproject it. I would prefer not to have GeoViews reproject it. So I think the right thing to do here is open up an issue and just have that discussion online asynchronously.
Yes, I agree.
All right, yeah, but hopefully GeoViews can get your problem solved there, Samir.
Yeah,
all right.
Samir, for the question.
So now it is time for our world famous rant section, where we each get 15 seconds to rant about whatever topic we want. Philip, it is your soapbox.
Okay, so I was hoping to avoid this, but I do have to rant about Brexit, unfortunately. The last 2 days have really crystallized how awful everything is. I, as a foreign resident, still don't have the rights to live here. They haven't guaranteed that I'm allowed to stay. And we still don't have a deal. So that's my main rant. I'll quickly get another rant in, which is a rant directed at ourselves, which is we haven't been doing well enough on community engagement in our projects. So I'd love anyone listening here to start contributing to our projects, providing us feedback to how we can help you get started on contributing and so on. So that's me.
Awesome.
David?
I saw a video recently. It was a sign language interpreter interpreting the Brexit discussions recently, and she was fantastic.
I saw that. I love that.
the befuddlement as she was signing. My rant today is I really love what LaTeX does, but often I hate LaTeX.
For my part, I have a huge pet peeve about using ratios to compare populations, for example, men versus women. We have wonderful entropy-based measures that are capable of capturing comparisons across more than two groups. Imagine that. My domestic partner, an epidemiology and public health professor, says that ratios are hard enough for the general public to understand, which is true. But we're data scientists by and large, and we should be able to interpret and understand better measures than ratios, which usually don't capture the whole system. That's all that we have time for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you are interested in funding open source projects, including GeoViews, you can find all of the project roadmaps at quansight.com/projects. Philip, where can people find you and GeoViews?
So GeoViews is just geoviews.org, or to get a good overview of everything in the Pybus ecosystem, just go to pybus.org. And then you can just email me at pridiger@anaconda.com.
Excellent. Excellent. Thanks, everybody, and join us again next episode for a lively discussion on SciPy with Ralph Gomers. It should be a good one, right at the end of the month. All right. Thanks.
Thanks
Bye.
for having me. Thanks. Bye.